Hey there, intermediate algebra students. Time for our last lesson in chapter 8 here. This is elimination once again, but this time part 2. Same type of problems, but just get a little bit more difficult. So again, our goal, remember, is to find a common solution. And we've done this by graphing where the lines intersect. We've done this by a couple of algebraic means like substitution and now elimination. If you recall from our last lesson, it was pretty basic because we were always looking for opposites, and we saw that when we added up columns, one of the variables always dropped out. And last lesson it was pretty nice because it was set up fairly well for us for those opposite situations. Maybe we had to do a little bit of finagling, but not much. Now in this case, you notice that there are really no opposites here with my x's or my y's. And so before we do some elimination, we're going to have to multiply one of the equations, or perhaps both of the equations, by something, so we set up that opposite idea. So there's more than one right way to do these, but my first thought here is I see a plus 3y. Would there be any way to make this a minus 3y? And yeah, sure enough, that if I multiply this whole equation by 3, like that, that would work out. And so I use my distributive property. I get 12x minus 3y equals 18. And meanwhile, my top equation, then, that doesn't change at all. So I'll just bring that straight across. So that's x plus 3y equals negative 5. But now notice, sure enough, I do have that opposite situation right here. And so now when I do add them up, and let's actually see what happens here. Remember, this is a 1x. So 1x plus 12x is 13x. Here's my opposite with my y's, so they cancel out. And then negative 5 plus 18 is 13. And so sure enough, I can divide by 13, and this works out pretty nicely that x equals 1. And then I have to take that x equals 1 and put it in place of one of the other equations. I'll probably put it way back in place of this one here. And so when I do that, I'll get a different color here. Then I have 1 plus 3y equals negative 5. I'll subtract 1 from each side, and sure enough I'll get 3y equals negative 6. And if I divide by 3, I'll get y equaling negative 2. So my final answer here, I'll change colors yet again, my final answer will be 1, negative 2. So definitely a little bit more work, but the key feature right here is multiplying by something that would create that opposite situation. Let's look. Alright, now notice this one. Again, we don't have any opposites with my x's or my y's, and it doesn't look like I could just multiply one equation by something to cancel things out. Looks like in this case I might have to multiply both of them by some value. So I am going to, looks to me like maybe the best situation, what if I got this to be a negative 10y and the bottom one to be a positive 10y? That looks like a pretty good strategy. So that means I'm going to have to multiply the top one here by 2. And if I do that, I'll get 4x minus 10y equals 22. And my second one, I will multiply that by 5. Again, I'm trying to get an opposite situation with my y values. So then if I do that, I get 15x plus 10y equals, 5 times 7 is 35, it looks like, right? Okay. Just got to make sure I did that right. Yeah, so that seems right. I'm just wondering about it. Looks like I'm going to have kind of a strange answer here, but I'm going to keep going with it and see what happens. So now when I add these up, I'm going to change colors here a bit. So when I add these up, sure enough I get 19. I'm just trying to figure out what I might have done wrong here, but I can't see anything right now. So I get 19x equals 57. No, I guess this is going to work out all right. And then if I divide both sides by 19, 57 divided by 19, sure enough, is 3. So that's kind of a nice number. And then I think I'm going to put 3 back in place of x in one of my earlier equations, doesn't really matter which one. I'll just go with the bottom one here. So instead of 3x, it's going to be 3 times 3 plus 2y equals 7. So that's 9 plus 2y equals 7. Subtract 9 from each side. I'm kind of running out of room here, and I get 2y equals negative 2. And so y is going to equal negative 1. So my final answer here then is going to be that the ordered pair 3, negative 1. So this is a kind of a complicated case where I have to multiply both equations in order to get my opposites right here. So that happens occasionally. All right, and we know the big play here is coming up the end of this week, all shook up. Hopefully all of you can go there. We have some of our class that's even in the play, so hopefully you can go and see those guys. Anyway, let's just show you how you can use a system of equations to solve kind of a real-life problem like that. So let's say at Thursday's premiere there were a total of 375 in attendance. That's adults and kids. Tickets were $6 for adults and $4 for students. How many students attended the play on Thursday? So believe it or not, you can figure out an answer to this. I just have to dig out my solution here a bit. So we can write two equations for this, and the first one would be, let me just change colors here slightly. First one, we know there is a total of 375 people in attendance, so we're going to say x plus y equals 375. And x could represent the adults and y could represent the students. And then the one thing I forgot to mention here that I should have in the problem is that there were $1,950 that were collected from everybody. So that means my next equation is going to represent something with the money here. So it's going to be 6x, $6 for every adult, plus 4y, $4 for every student, and that's going to equal 1,950. So there's my system of equations. Again, I'm going to try to get rid of one of these variables here. And so I think you see what I'm going to end up doing here is multiplying one of these equations by something. And probably a good idea, I would say, let's multiply the top one by negative 4 and see what we get. So then I'm going to end up there with negative 4x minus 4y, and I got to get my calculator out here and do 375 times 4. Let's quickly do that. And 375 times 4 looks like that's going to be 1,500, but because it's negative, I have to write it as negative 1,500. Alright, so then I can combine that with my other equation. I'm just going to rewrite that in yellow here. Kind of running out of room, as you can see. But now when I add these up, my y's will cancel out. I'll get 2x equals negative 1,500 plus 1950. Looks like that's going to end up to be 450. So I can solve this for x. Kind of running out of room here, so I'll talk you through it. If I divide both sides by 2, I guess I can barely sneak that in there, I'm going to end up with x equaling 225. So x would be the adults because they're the ones that paid the $6, and the problem asks for me to figure out how many students were there. Well, again, I can put this 225, that's the number of adults, I can put that in place of this x, and so I really then have the equation 225 plus y equals 375, and if I subtract those 225 from each side, I'm going to get 150. And so there's my answer there, is that there are 150 students in attendance. So that's an example how we can use a system of equations to solve kind of a real life problem. Alright, thanks for listening everybody, and we'll see you guys in class.